Welcome to Homework Lib.
Here we're given for different liquids described in the table below, and we want to order them in terms of the lowest freezing point and of the higher boiling point. So remember that this is part of the colligative properties of matter, and we know that the change of the freezing temperature is going to be equal to minus I times hygroscopic factor times the molality. We're going to have a similar expression with the boiling point, but with I times hygroscopic constant times molality. So what this means is that the solution with the highest molality of a solute is going to have the lowest freezing point and the highest boiling point. Now, we also need to consider if the solute is going to be an electrolyte or a non-electrolyte. So, for example, for a non-electrolyte, the Van Hoff factor is going to be equal to 1, and for electrolytes, it's going to be equal to the number of ions that are going to dissociate. For electrolytes, so for example, for sodium chloride, this is going to dissociate into Cl plus Cl minus, so the Van Hoff factor would be equal to 2. The same thing is going to happen with potassium chloride. The Van Hoff factor would be equal to 2. And in the case that we had a different salt, so for example, let's say iron chloride, this dissociates into iron 3 plus Cl minus, 3 of them. So the Van Hoff factor would be equal to 4. Okay, so we need to take this into account. So in these cases, the only thing that we need to calculate is the factor I times M. And in this way, we're going to be able to measure each of them. So in the first case of potassium chloride, remember that the amount of mole is equal to the mass divided by the molecular weight. So for potassium chloride, we're going to get 5.6 grams divided by 74.55 grams per mole. Let me put it over here like in a different box below the explanation. So the amount of mole would be 0.075 mole of potassium chloride. Next up, of sodium chloride, we're going to have the same mass divided by a different molecular weight. Now we're going to get 58.44 grams per mole, which is 0.096 mole. And finally, for glucose, which is C12H22O11, we're going to have the same amount, 5.6 grams, divided by the molar mass, which corresponds to 180.16 grams per mole. So 0.031 mole. As you can see, the one that is going to have the lowest molality, because we know that molality is equal to amount of mole of solute divided by kilogram of solvent, we're going to have the following order. The one with the highest molality is going to be sodium chloride. The lowest molality is going to be sucrose in this case. And the intermediate molality is going to be potassium chloride. Now, if we take into account the Van Hoff factor, the trend is going to stay the same because sucrose, since it is a non-electrolyte, we just need to multiply the molality times 1. So the change of temperature is the same as the molality times the coroscopic constant. And in the case for the two electrolytes, both of them have the same Van Hoff factor. So for potassium chloride and for sodium chloride, the Van Hoff factor is equal to 2. So both of them are going to have the same contribution. So we can compare directly the molalities. Now, let's order them in terms of the lowest freezing point. One is going to be the one with the lowest freezing point. We said that the highest molality, the highest lowest point. Sorry, the lowest freezing point. So, highest molality, 1. Next up, the intermediate one, 2. Next up for sucrose, 3. And for pure water, molality is equal to 0, so we don't have any change of temperature, so we're going to get 4. Now for the boiling point, the highest molality corresponds to the highest boiling point. So over here in the instructions, select one next to the liquid with the lowest boiling point. The lowest one is going to be water in this case. Next up, the one with the lowest molality would be sucrose. Next up, intermediate one, 3, and final with the highest boiling point is going to be 4. So this is going to be the trend that we want to get. As you can see, we don't need to calculate directly the molality in these cases. If you want to do it, you just need to multiply all of these quantities by 0.1 kilograms because we have 100 milliliters of water. So for example, molality of KCl would be equal to 0.75 molal. Molality of NaCl would be equal to 0.96 molal, or mole per kilogram, to not confuse it with mass. And the molality for glucose, H22O11, would be equal to 0.31 mole per kilogram of solvent. So that would be all. Thank you very much and have a good one.